So here we have a website that has pages inside of it for people from various different categories who might be converging on the site to help as volunteers. There are fire and rescue people, police officers, rescue dog handlers, structural engineers, and social workers. For each of those people, there's a page behind this, this home page that tells them where they should go, where they're needed, what they need to bring, all that other sort of information. But this particular web server is a legacy web server. Oh, and I should add, you don't want to give this information out to just anybody. So if you need rescue dogs to search through the rubble of this collapsed building, you don't want gawkers going down there and getting in the way and standing around. You want to get the volunteers where they're needed and not send people who are not needed to that place. So the information in this site is sensitive, and you want to get it to the right people, but only to the right people. So this is a legacy website, so the only thing it has protecting it is a password. And obviously a volunteer who's coming in, let's say a volunteer rescue dog handler, they don't know the password. They don't have an identity on this site. This role they're trying to authenticate to, rescue dog handler, they don't know how to do it. So in this demo, what we've set up is this website has delegated the task of credentialing and giving out passwords to a Traust server. So the Traust server, this is a Traust client. The Traust server is running on a machine back at Illinois, Rose. And to trigger the trust negotiation, all I need to tell that server is what role, what resource I'm trying to access. In that case, it's the home page for rescue dog handlers. So as I toggle between these roles, the home page information at the bottom changes. So if I copy that over to this Traust client and start a negotiation, in a little time it's going to come back, because I do have the right credentials, and we'll talk about what those were in just a minute. It's going to come back and tell me this really secretive-looking password called handler password. And then I can use the handler password to log into the website. And yes, I got into it. Here's the information for search dogs and their handlers about where they need to go, what they have to bring with them. There's no water, you have to bring water. Report to the staging area, here's where the staging area is, and so on. Okay, so here we have a legacy server and also a legacy client, because I ran that Traust thing by hand, and we're still making, being able to use trust negotiation to establish trust on the fly. So the thing that's interesting about this demo is that the policies are actually extremely complicated, and we'll go back to the PowerPoint and talk about what was happening in the background that we didn't see during the demo. Okay, first, Traust has this same ability that we've seen in the case of TrustBuilder to protect sensitive information and access requests. And as we'll see on the next slide, that was used in this rescue dog example. We'll see how it was used in just a minute. So if Alice decides that the Traust authorization server is trustworthy enough that she's willing to tell it what resource she wants to access, then the second step, the second phase, I should say, is that she actually tells the server what resource she wants to access. In this case, the home page for rescue dog handlers. And the way Traust is set up, a single Traust server could protect just a single web page or a whole enterprise, a whole set of web pages. So it's very flexible as to the granularity of protection and the number of resources it's protecting. Then an ordinary trust negotiation takes place to make sure the client is authorized. And if that trust negotiation shows that the client is authorized, the client gets one of these legacy-style credentials that it can use to access the resource. And in the demo, it was a login and password, which is really very old-fashioned. It could be something more modern, like an X509 proxy certificate. It could be a Kerberos ticket, a SAML assertion. Anything like that would work. The Traust server can give anything like that out. And it could be a credential that Traust has previously stored, like it's already got the Kerberos tickets and just waiting to give them out, or it could generate them on the fly if we don't think that that's too dangerous. So what happened during the demo? Here's the rescue dog handler, Alice. She's got various credentials and policies, and so does the Traust authorization service used by DisasterNet. Alice was a little paranoid, and she wasn't willing to tell just anybody that she was going to access this disaster site. She's only willing to talk about the fact she's a rescue dog handler to sites that are certified by a U.S. state as being a disaster response coordinator site. So this whole process starts by Alice telling that policy to Traust. Traust is one of, the website that Traust is protecting is one of these official disaster response coordinator sites, and it's willing to show that credential to anybody. So it sends it back to Alice along with a chain that shows that that credential is issued by the state of California, which really is a state. Next, Alice says, okay, well then I trust you enough to tell you that what I really want to access is the rescue dog handler role. Okay, and in the little pop-up call-out, it's the details of what that request looks like. Well, there's a kind of complicated policy for rescue dog handlers. First, you have to have a search team credential that's issued by a certified search organization. And one of those is the American Rescue Dog Association. I actually don't know what NDSDF is because my student's a much bigger dog buff than I am. You also have to have a driver's license to prove you're over 18. They don't want very young people searching for bodies in the rubble. The driver's license has to be issued by a U.S. state. You need to prove that you have a valid tetanus shot by showing a record that's issued by a board of health that's certified by a U.S. state. And you have to prove that the dog has had its rabies shots. So that's pretty complicated. But Alice is willing to show her search team credential to this Traust server because she already knows it's a disaster response coordinator site, and she's willing to show her search team credential to any disaster coordinator site. But the medical records, she's not so forthcoming about. She'll show it to a government agency, a department inside a state in particular. And for her driver's license, she wants to know that the site she's showing it to adheres to some sort of privacy policy that's been certified by somebody. Well, this particular site does have that privacy policy credential, which it got from Trustee, and it is part of the state of California. It's willing to prove that to Alice. So Alice is willing to send to Traust her medical records and the driver's license and the dog's rabies shot information. And then finally, after all that, Traust sends Alice the password that she needs to access the rescue dog handler. So there's actually a lot going on in the background, and it's really nice that the user didn't have to deal with this directly at runtime. So the protocol that the software entities were using to talk to each other during the demo was on top of TLS. TLS was the transport layer. The protocol is a lot like the MyProxy protocol that's used in the grid security infrastructure. It's a very simple protocol where people send commands to each other and they get back responses. And in our case, there are only 4 important types of commands. There's a get info command, which you could use to get metadata about a server. There's an initiate trust negotiation command, and then the negotiation goes on until you send a end trust negotiation command. And as part of the negotiation, you may say what resource you want to access, and that's the resource request command. So a very simple protocol wrapped around TrustBuilder software.